Hello. Today, let's describe. Let's do a brief description on neural networks. So, what are the topics we're going to discuss? First, what is neural network? The next, what are the components of neural networks? And what are the functional components of neural network? And then, working off a simple neural network model. So, let's discuss or let's see what is neural network. Neural network is simple. It's a machine learning model which mimics the way how human brain works or human brains process the information. So it consists of interconnected nodes which are called neurons, which is an analogy to biological neurons. And next, what are the components of neural networks? It consists of three layers: input layers, hidden layers, output layers. What does the input layer does? Input layers get the information, get the data. Okay. This is the entry point. Then what does the hidden layer does? Hidden layers is an intermediate layer which process the data. Hidden layer process the data and then it fits into the output layers. Output layers is the final output. So say this is the input layer, this is the input layer, then we have the hidden layers, and then we have the output layers. So input layers will get the information, feed it to the hidden layer process it, and then gives out to the output layer. That's simple. So in between there are some mathematical calculation happening there. Okay, let's move to the next. What are the function components of neural network? Basically there are two function components. You can add one mathematical function later. The two function components are the weights and the bias. What is weight? Weight is basically a numerical value assigned to the interconnected nodes. And then what is a bias? Bias is just a factor which is being added to the output to shift the model or to balance the model. So this is the model. So there is an input layer, hidden layer, output layer. So input layer we have say contains x1 and x2. So x1 and x2 will connect with the hidden layer. Say this is h1 with is connected using a weight. Okay, weight. And then x2 will be connected with say h1 also using a weight. And then it will add the bias. Add the bias to the hidden layer. So we add here, add the bias. Yeah, b1. So how will this be represented? So we have h1. So this is a some numerical calculation. So x1 w11 plus x2 into w21 plus bias. So this we get this h1 using this weights and bias. In short, we can write this in the summation form. Then again we have h2. How do we get it? From the x1 we get the weight. From the x2 we get the weights, add the bias, and then we get h2. So h2 is like this. In the short form we add. Similarly, we will have h3, add the weights, two weights, and the bias, we have h3. Then for h4, the weights, the two weights, the bias, and then we get h4. And after this, what do? We don't directly feed h1 to the output layer. What do? We add a function here. What is this function called? is called activation function. It decides whether this node should be activated and passed to the output layer or to the another next layer or not. So this is called the activation function. This activate the nodes. So what is the activation function? It is just a mathematical equation which introduces non-linearity and determines whether the neuron should be fired, activated or not. So if we don't use this function, it becomes a linear model. Okay. So add the function here. Add the function. We use activation function to h1, then we get h01. Similarly, we add the we uh, use the activation function in h2. We get h2, h02. Similarly, we'll have for h3. We have for h4. Okay. So then this node, this layer. So we connected the node with the weight from H01, then H02 we have the weight, then H03 we have the weight, then H04 we have the we have the weight. Then here also we need to add the bias, then we get 0 1. Similarly, then we get the 0 1. There we have the function. How does it like? H01 into weights plus H02 into weights. So 3 into weights, H04 into weight plus bias. Okay, so these are the short form. So next we add for 0 2 output. So we have the weights from H1, we have the weights from H2, we have the weights from H3, we have the weights from H4, then we will add the bias, then we get the output 2. So here this is the output 2, the function, the summation format, and then again here we need to wait the activation. We need to implement the activation function in the output layers. In the output layers, okay, some common kinds of common activation functions are uh, 10h, sigmoid, softmax, ReLU. 10h ranges the values from -1 to 1, sigmoid from 0 to 1, softmax also 0 to 1, and what's that? ReLU ranges from 0 to infinite values. ReLU doesn't have a negative. ReLU doesn't have a negative value. Okay, we apply the activation and here we apply the activation function and then we get output 0a. So output 0 is applying the activation function on 0 1. Similarly, we apply the activation function on 0 2. So in fact O2, then we get the output OB. OB, yeah, that's all. Thank you.